Hello everyone. In the last part of kinematics of particle, we dealt with that rectilinear motion with variable acceleration. Now in this part, we will be dealing with the curvilinear motion. Let us see what is this curvilinear motion. We already have seen that rectilinear motion means it is motion along the straight line. So this curvilinear motion, it means it is the motion along the curve. Many more examples are there for the curvilinear motion from our day-to-day life. It can be the bullet fired from a gun, it can be the ball thrown from one place and the player catching it at the another place, or even it is falling at the ground. Here you can see some of the actual examples of that curvilinear motion, that how do we deal in our day-to-day life. This is the another example that something is fired from that ground level and the monkey is catching it and then it is coming back to the ground. So the path followed by that particle, that is nothing but the curvilinear path, or sometimes it's a parabolic path. So this motion is called as that curvilinear motion. Then in this curvilinear motion, some of the basic terms are there. Like first we need to define the position vector. So what is that position vector? So here it is shown that the path is along the curve, means this is the curve path which is followed by the particle. So at some particular instant this particle is at point P. So for this point P, first of all we need to define its position. So to define the position of this particle, we take the help of those coordinates or the vector form. So in vector form, we can define this position as vector r is equal to xi plus yj plus zk if it is along the 3 dimensions. And as per our syllabus, if we are converting into its 2 dimensions, then this position vector will be simply written as xi bar plus yj bar only along the 2 directions, that x and y. And based on this position vector, that position of the particle can be calculated by using this equation, that under root of x square plus y square plus z square. For 3 dimensions, this equation is applicable. If we are dealing with 2 dimensions, then that equation will be only r is equal to under root of x square plus y square, and we will get the position of that particle. Next to the position, there is the displacement and distance. How do we calculate this displacement and distance? So first, initially this particle is shown at point P. This one frame of reference is considered here, and this position r with respect to this frame of reference is denoted for the particle P. Then within some interval of time t, that delta t interval is taken and this particle is moving from P to P dash. So after that time delta t, this particle is now at the position r plus delta r with respect to the same frame of reference. Hence, the total displacement of the particle will be only this delta r, but the distance travelled is this delta s. Here you can see the difference. In one of the previous parts, we already have discussed what is the displacement and what is the distance. Distance is the total path covered by the particle. That is why from P to P dash, whatever the path it is covering, that total path is taken as delta S. And the displacement from P to P dash is just the position between the final position and the initial position, that is delta R. Hence the displacement is taken as delta R. Now based on this displacement and distance, then the velocity is calculated. First we calculate that instantaneous velocity, and then by applying the limits from time t delta t to 0, the average velocity is calculated, and this average velocity is the dr bar by dt, means velocity, that rate of change of displacement. So with the help of that we can get the velocity. Next to the velocity there is acceleration. Acceleration is rate of change of velocity with respect to time. So that average acceleration becomes this dv by dt. Then in this curvilinear motion, different coordinate systems are followed. So these are the different coordinate systems, like rectangular coordinates, then normal and tangential coordinates, and radial and transverse coordinates. So that normal and tangential coordinates are also called as the path coordinates, and radial and transverse coordinates are also called as the polar coordinates. In these rectangular coordinates, many more examples are there, or that rectangular coordinate is nothing but our actual rectangular coordinate system, that is x, y and z components, or else that I, j and k components in the form of vector. So here first let us see how to find out those rectangular coordinates and how to use those rectangular coordinates to find out the velocity and acceleration. So for rectangular coordinates, this one system is shown. This is the path which is followed by the particle. The direction is also shown, means that particle is following this direction along the curve, and at some point A that position is taken. So for this point A, its position is defined as x and y. So in the form of vector, that position will be written as xi bar plus yj bar. It's a position vector at this point A. Based on this position vector, then we can find out the velocity. So that average velocity is dr by dt, means that rate of change of position with respect to time. As this is rate of change of position with respect to time, it is also denoted by r dot. So this r dot will be equal to this xi, means this equation will be written as dr bar by dt. It means d by dt of xi bar plus d by dt of yj bar. So that d by dt is denoted by this dot over the head. Hence this is written as xi dot plus yj dot. So within this term, we can get now that x component and y component of the velocity. So Vx, it is equal to dx by dt, that is nothing but x dot, and Vy, it is equal to dy by dt, it is equal to y dot. So here you can see these components where this velocity is shown. The velocity is shown tangential to the path, means this is the point under consideration. So to the point under consideration, here one tangent is drawn in the direction of the path followed by particle. So the particle is following this path. So along the same direction, that one tangent is drawn, and that is the total velocity at that point. And for this velocity, then its components are derived, that x component and y component. So this x component is dx by dt, it is equal to x dot, and y component is this dy by dt, it is equal to y dot. And for this velocity, its inclination is taken as alpha with respect to x. Hence that tan alpha will be equal to Vy upon Vx, and the total magnitude of the velocity will be under root of this Vx square plus Vy square. Similarly, then there is acceleration. Now this acceleration is perpendicular to the velocity. Hence this acceleration is shown over here. It is perpendicular to the velocity towards the center of that path. So as per that, this acceleration direction is shown and its x and y component is defined. This is ax component and this is ay component, and the inclination of this acceleration with respect to x-axis is denoted by beta. So for that acceleration, we just now saw it is the derivative of time, means rate of change of velocity with respect to time. It is nothing but v dot d by dt of v bar, that is v dot. It will be equal to d by dt, just take this term, d by dt of vx plus d by dt of vy. It means vx dot plus vy dot. So within this we can define that ax component is equal to dvx by dt, it is nothing but vx dot, and ay, it is equal to dvy by dt, it is equal to vy dot. And the total magnitude of the acceleration will be this under root of ax square plus ay square, and this inclination with respect to x-axis will be found out by using the tan beta is equal to ay upon ax. So here we can sum up all the vector components for the rectangular coordinates, like position is given as xi bar plus yj bar, then that velocity it is vxi plus vyj, and acceleration it is axi plus ayj. So all these terms, that x, vx, ax, or here y, vy and ay, those are the rectangular coordinates for that one particular point. Then next to these rectangular coordinates, there is the radius of curvature. By using these rectangular coordinates, that radius of curvature can be found out by using two different things. First one is when that path is the equation that y is equal to f of x. So there, that equation for radius of curvature is given as 1 plus in bracket dy by dx bracket square raised to 3 by 2 divided by d square y by dx square. How to find out this dy by dx? We have the terms dy by dt, then dx by dt. Just put those terms over here, that dy by dt upon this dx by dt. So by putting that, we will get this equation of dy by dx. Similarly, here also the equation can be found out by using the same thing, by applying the chain rule. And hence this total equation is used to find out the radius of curvature. Next to that, when the rectangular components of velocity and acceleration are known. Velocity and acceleration means now it will be known in terms of vx and vy and ax and ay. So this radius of curvature is found out by using this equation vx square plus vy square bracket raised to 3 by 2 divided by vx into ay minus vy into ax. If we are solving this term, that vx square plus vy square, then it is v square, that magnitude of the total velocity v square. So it will become v square raised to 3 by 2. So by solving that, it will become v cube divided by vx into ay minus vy into ax. Hence, by using the rectangular coordinates or the rectangular components, that radius of the curvature can be found out by using these two equations. Those are depending on the availability of the function. So here that one example is taken related to this coordinate system. The y coordinate of the particle is given by, this equation is given, y is equal to 6t cube minus 2t. And if ax is equal to 10t meter per second square and vx is equal to 5 meter per second at t is equal to 0, then calculate the magnitude of velocity and acceleration of particle when t is equal to 1 second. So first let us write down the given thing as it is. The equation of y is given, that 6t cube minus 2t. Ax and vx are given when t is equal to 0, and we are asked to calculate the magnitude of velocity and acceleration. It means here the total velocity and total acceleration is to be found out. So for total velocity, we already know that equation, v is equal to under root of vx square plus vy square. Here vx is known, we just want vy. Similarly for total acceleration, it is under root of ax square plus ay square. Here ax is given, we want ay. So how to calculate that? So for that calculation, this equation will help us. Let us see how it is helping us. So here first that equation is written as it is, that y is equal to 6t cube minus 2t. Now differentiate that equation with respect to time. So it will become dy by dt, that is nothing but vy. So it will 12t square minus 2. Again just differentiate this equation with respect to t. So it will be d square y by dt square, that is nothing but dvy by dt, it is equal to ay. Here we are getting y component of the acceleration, that is 24t, and here y component of the acceleration, y component of the velocity as 12t square minus 2. We are asked to find out the total velocity and acceleration at t is equal to 0, t is equal to 1. So just put t is equal to 1 in these two equations. That is at t is equal to 1 second, vy will become 10 meter per second and ay will become 24 meter per second square. Then let us come to the second given condition, that ax is given as 10t and vx is equal to 5 meters per second at t is equal to 0. Now from this ax and vx, let us integrate that to get the further things. Hence ax, it is nothing but dvx by dt, as here we are giving ay is equal to dvy by dt. Similarly here ax is equal to dvx by dt and it is given as 10t. Means dvx is equal to 10t into dt. So just integrate this term, that integration dvx is equal to integration 10t into dt. So the equation of vx will be equal to this 10t square divided by 2 plus c1. c1 is the constant of integration. To get this c1, use that given condition. What is the given condition? Vx is given as 5 meters per second at t is equal to 0, and this is the equation for vx. So put vx is equal to 5 and this t is equal to 0. So by that we are getting c1 is equal to 5, and hence the equation of Vx will become 5t square plus 5. Now put the t is equal to 1 second in the equation of Ax and in equation of Vx. So here we are getting those values, that Vx as 10 meter per second and Ax as 10 meter per second square. Now we have got all the four values, that Vx, Ax, Vy and Ay. Then find out the total velocity. Total velocity is under root of Vx square plus Vy square. So Vx square is 10 square plus Vy square is again 10 square. So the total velocity is becoming 10 meter per second. And A, it's a total acceleration. It is under root of Ax square plus Ay square. So Ax square means it is the 10 square plus Ay square means it is 24 square. Under root of that you will get the magnitude of total acceleration as 26 meters per second. So likewise the equations or the numericals related to the rectangular coordinate system can be solved. If the equation for x or y is given, then we just need to take the differentiation to get the equations for velocity and acceleration. And if acceleration or velocity is given, then we need to integrate that to get the position or to get the further part, and then we can calculate this magnitude of the velocity and acceleration. In addition to this, here even we can calculate that inclination between the velocity and the x-axis, like we saw that tan alpha is equal to Vy upon Vx. So we can find out that Vy upon Vx, and tan beta for acceleration, that inclination of acceleration, it is tan beta, it is equal to Ay upon Ax. So those inclinations can also be found out by using these equations. So this was the rectangular coordinate system. Another example of the rectangular coordinate system is projectile motion. So in the next part we will be dealing with the projectile motion. If you have any queries within this, you can mail me so that I can solve your queries related to this rectangular coordinate system. Thank you.